An AV system is two or more pieces of AV equipment designed to work together to meet a communication need. The technology that supports much of the AV industry is changing from analog to digital. You need to understand both technologies. One way to understand analog signals is to create a mental image. Think of a dimmer light switch, which offers many possible positions, analog represented as continuous varying wave. However, digital information requires a different mental image. Think of a standard light switch, which has only two positions on and off. In the world of signals, a digital signal is either on or off. These two states are numerically represented with a 1 on or 0 off. AV professionals need to know about digital signal processing, sampling, bit depths, and bit rates. They also need understanding of signal compression and digital formats. For digital signal processing and sampling, you may have an analog source material that you need to make digital. For example, you might need a digital copy for streaming content over the internet, for archiving purposes, or sending through an AV system for use elsewhere. Sampling is one important step of the analog to digital conversion. The goal is to make a reasonable digital copy of the original analog signal. A digital sample of the analog signal is made at certain time intervals. How often a sample is taken is called the sampling rate. Determining an acceptable sampling rate is crucial to obtaining a digital representation that resembles the original signal. For example, the sampling rate of an audio CD is 44.1 kHz, KHZ. That means 44,100 samples are taken every second. These samples are recorded and stored for later use in replication or playback. The technique is called post-cold modulation, PCM. When you take a sample at twice the frequency of the signal, you are using the Nyquist rate. The resultant digital representation of the analog signal more closely resembles the original analog signal. You can also begin to see how higher sampling rates produce a much better representation. Bit depth of a digital signal. The sampling rate determines the digital signal's accuracy, how closely it captures the frequency of the original signal. The precision, how close the digital signal is to the analog signal's amplitude values, is determined by the sample's bit depth. Bit depth is defined as the number of states you can have in which to describe the sampled voltage level. If you have one bit, whose value can be 0 or 1, you can describe the signal as being only on or off, 2 states. If you have 2 bits, you have 4 possible states, 0, 0, 0, 1, 1, 0, or 1, 1. In which to describe the signal. Bit depth in digital video signals is a measurement of how many shades can be displayed. Each possible color is a state. The greater the bit depth, the more realistic the image will look. A black and white display is called 1 bit because it allows only 2 states, black and white, which is 2 to the power of 1. A 16 color display is called 4 bit because this is 2 to the power of 4. The next level is 256 colors, which is 2 to the power of 8, or 8-bit, and so forth. Bitrate. Bitrate is a measurement of the quantity of information over time in a digital signal stream. It is quantified using bits per second, bits or BPS, where 1,000 bits equals 1 kilobyte, and its rate measured in kilobytes per second, kbps. And 1 million bits equals 1 megabyte, and its rate measured in megabytes per second, mbps. Generally speaking, the higher the bit rate, the better the quality. Signal compression. Compression allows us to reduce the very large original files to practical, more manageable sizes. To compress something is to make it smaller in some way. The process of digitally compressing content is used extensively in computer applications such as streaming audio or video content over the internet. Compression is also useful for text files. By discarding data that is not required, we get compressed files. Text files are full of spaces between words that are represented by groups of data. These groups of data can be compressed very tightly without affecting the characters, resulting in much smaller file sizes. Compression technology reduces the size of digital files and makes them easier to transmit and store. However, the more you compress a signal, the more you affect its quality. If you remove too much data, the effect can be seen in image files and heard in audio files. One frame of uncompressed digital video at a resolution of 720 by 480 requires about 1 megabyte of storage. At 30 frames per second, that's about 1.9 gigabytes per minute of video. Imagine how much space a 10-minute video would occupy. Standard digital video DV cameras usually compress at a ratio of 5:1. Some video formats offer much higher compression rates. Two important steps in the compression process are encoding the digital file to make it smaller and decoding the file so it plays back properly. These steps are accomplished using one of many codecs. A codec is a piece of equipment or software that employs a computer algorithm or a set of procedures to encode or decode file information. There are different types of codecs that are specialized for different purposes, including audio codecs and video codecs. A codec encodes a data stream for transmission, storage, or encryption, or it decodes a data stream for playback or editing. Digital formats. A digital file contains two elements. Container. The container, such as WMV for Windows Media Video, is the structure of the file where the data is stored. The container defines how the data is arranged to increase performance and which codecs are used. Codec. The codec provides the method of encoding, compressing, and decompressing the file. Many video and audio codecs are in use today, and new ones are constantly being created. In most cases, the codec must be installed in the operating system to play the file. Thank you for watching, and I hope you have a great day.